This is my doctor, and let's begin with present basis for the classification of elements. The present basis for the classification of element is the atomic number of elements. The atomic number of element is equals to the number of protons in an atom of the element. Since the number of protons and electrons in an atom is equal, so we can also say that the atomic number of element is equals to the number of electrons in an atom. It helps in arranging the elements according to their electronic configuration. So we can say that the present basis for the classification of element is the electronic configuration. In the year 1913, Henry Moseley showed that the atomic number of an element is a more fundamental property than atomic mass, and hence atomic number is a better basis for the classification of elements. The atomic number increases regularly by 1 from element to element, but atomic mass does not vary regularly from one element to the next. No two elements can have the same atomic number. So it was the discovery of atomic number which led to the change in a Mendel's product law, which was based on the atomic mass. So let's discuss about the modern product law. The modern product law is based on the atomic number of an element. The modern product law states that the properties of elements are a product function of their atomic number. The modern product law means that if elements are arranged in a tabular form in the order of their atomic number, then the elements having similar properties will occur after fixed intervals or periods. Actually, when elements are arranged according to increasing atomic numbers, there is periodicity in the electronic configuration of elements. The periodicity in the electronic configuration of elements leads to the periodicity in the chemical properties. The elements having similar electronic configuration show similar chemical properties. So let's look at the modern periodic table. The modern periodic table was prepared by Niels Bohr. It is also known as the long form of the periodic table. In the modern periodic table, the elements are arranged in the order of increasing atomic number in horizontal rows called periods. We place under each element all the other elements having the same number of valence electrons, so that all the elements having the same number of electrons come in the same vertical column or group. Since the elements have same number of valence electrons, show similar properties, therefore all the elements in a particular group of the periodic table has similar properties. It is obvious that the arrangement of elements in the modern periodic table is based on the electronic configuration. The modern periodic table is shown here. The horizontal rows of elements in a periodic table are called periods. There are 7 periods in the long form of periodic table. The elements in a period have a consecutive atomic number. The number of elements in each period are like that. In the first period, it contains the 2 elements. In the second and the third period, it contains the 8 elements. And the fourth and the fifth period contains the 18 elements. And in the sixth period, it contains 32 elements. While in the seventh period, it contains the rest of the all elements. So it is incomplete period. The number of elements in a period is fixed by the maximum number of electrons which can be accommodated in the various shells of an atom. For example, the first period has 2 elements because the first shell or K shell of an atom can take a maximum of 2 electrons only. Similarly, the second period of the periodic table has 8 elements because the maximum number of electrons which can be put in the second shell or L shell of an atom is 8. The figures 2, 8, 18, 32 representing the number of the elements in various periods actually corresponds to the maximum number of electrons which can be put into the various shells of the atoms. The vertical columns in a periodic table are called groups. There are 18 groups in the long form of the periodic table. So the group 1 is on the left side and the group 18 is on the extremely right side of the periodic table. The elements in a group do not have consecutive atomic numbers. The group 1 to 2 and 13 to 17 contain the normal elements. In the normal elements, all the inner shells are completely filled with electrons. Only the outermost shells are incomplete. All the elements of a particular group of normal elements have the same number of valence electrons in their atoms. In other words, all the elements in a group have similar electronic configuration and show similar properties. For example, group 1 consists of alkali metals, lithium, sodium, potassium, etc. all having one valence electrons in their atoms. Since all the alkali metals have similar electronic configuration, they show similar chemical properties. Group 17 contains halogens like fluorine, chlorine, and bromine and iodine, etc., all having 7 valence electrons. Since they have the same number of valence electrons of the halogen gas, they show the similar properties. The group 3 to group 12 are called transition elements. In these elements, the outermost shells as well as the next to outermost shell are incomplete and in the process of being filled with electrons. The elements with atomic number 57 to 71 are called lanthanoid series because their first element is lanthanum, and the elements with atomic number from 89 to 103 are called the actinide series because their first element is actinium. There are two series of elements having similar properties and they have been placed in the two rows at the bottom of the periodic table. In the modern periodic table, the elements have been roughly divided into metals and non-metals. The elements on the left hand side are the metals, whereas those on the right hand side are non-metals. In the periodic table, metals have been separated from non-metals by some elements called metalloids, which are placed diagonally in the periodic table. These metalloids are boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. The properties of metalloids are intermediate between those of metals and non-metals. The metals lie on the left-hand side of the metalloids, whereas the non-metals are on their right side. The noble gases, which are also called the non-metals, are placed on the extremely right side of this periodic table. So now let's discuss about the position of hydrogen. Hydrogen element has been placed at the top of group 1 above the alkali metals because the electronic configuration of hydrogen is similar to those of the alkali metals. Both hydrogen as well as the alkali metals have one valence electron each. Since hydrogen atom is very small in size, many properties of hydrogen are different from those of alkali metals. Therefore, while discussing the alkali metals of group 1, hydrogen is never included. In some of the periodic tables, however, hydrogen is not placed in any group. Hydrogen is treated as a very special element and placed alone at the head of the periodic table. So that's the idea about today's lecture. I hope you enjoyed my lecture. See you in next video.